Hello, year 13. Today we are going to work in derivatives. This is Derivatives 101, where we are going to see derivatives from scratch. So please make sure you have by yourself this document where all formulas are going to be used. So let's begin. First, we are going to start with this formula, which is the derivative of a constant. So any constant, as you can see in the formula, the derivative is going to be 0. A constant, it means that it doesn't have x. Sorry, it doesn't have x. So, for example, here, if you do the derivative is just going to be 0. This is very useful, especially because sometimes you can see something tricky. Let's say if you see an exercise that has a bunch of things, I don't know, 7 to the power of p plus, I don't know, e to the power of tangent of 45. Since you don't see anything with x, these are just numbers. The derivative is just going to be 0. And that's it. Now, we got a second most important, in my opinion, derivative, which is the derivative of x. The derivative of x is just 1. So whenever you see x and you think about the derivative, it's just 1. With that said, it's important to see that also if, well, like in this exercise, if we are going to do the derivative, we have a number in the front of the x. This is not going to change a lot of what we know. Whenever we have a number that is multiplying the x, we just ignore the number and we just do the derivative of x, which is 1. So for example, in this exercise, if we do the derivative, you will find out that I have minus 5x, but I don't care about the minus 5. I will take a look at the x, I will take a look to the table, and I'm going to find that the derivative of x is just 1. If you have a number multiplying that x, then it's going to be just that number. As you can see, we just copy the minus 5 right here, and we did the derivative of x, which is just 1. So this is minus 5. This is like saying minus 5 times 1, but nobody really cares about the 1. That's why we don't write it in math. So minus 5, we copy, and the x was derived. Well, and then we got the 7. So if we do the derivative of 7, that's just 0. And our final answer is going to be just minus 5. And that's it. Okay? So checking this, let's move forward. We got the power rule. The power rule is, I would say, is the most important derivative formula that we are going to do. The power rule, which is this formula, is going to work for 99% of the times. Now, as you can see, the only thing we have to do is check for the x, check for the exponent, and the only thing happening is that the exponent, it goes down with multiplication. And we copy the same x, and we just subtract 1. So, for example, for this formula, for this exercise, we are going to do 3 times x, and then instead of n minus 1, n is 3. So we have 3 minus 1. Like I explained in class, I would like you to take a look. This 3 is the same as n right here. So according to the formula, I have to copy down here, I have to put it here. That's literally what we are doing. We are using the formula and we are just instead of putting the n, putting the number. As a result, here I forgot the line. As a result, the derivative is going to be 3x squared. And that's it. Following the same logic, we have these other numbers. And well, when we have something that does multiplication, and we do the derivative, the only thing we have to worry about is about the numbers. Although I say you have to ignore them, they are going to multiply the number that goes down. What do I mean by that? Okay, the number 4 here, for example, I am going to copy, and I'm going to do the derivative of x squared. According to the formula, if I want the x squared to be derived, I'm just going to put the number down. Let me put the number down, 2. Then we have x, and then we have the same exponent but subtracted 1. So as you can see, the 4 and the 2, they will multiply later. We do the same with the rest of exercises. So we have minus 6x. So now it's just minus 6 because the derivative of x is 1. Please remember that. And we got the derivative of 2, which is just 0. Now, if we continue with this, 4 times 2 is just 8. And we just copy the x. Minus 6, minus 6. So as you can see, here let me put an arrow to make it more organized. So as you can see, we finished this derivative. And for the ones that you are struggling with this, don't worry, we have these more exercises. I'm trying to be as most explicative as I can. Now, if we continue with this, for example, we have x to the power of 5. We know we have to follow this formula. Instead of n, we have 5, right? Instead of n, we have 5. So what is going to happen is that the number 5 goes down. We copy the same x. And instead of writing x5, we need to subtract 1. So this is going to be 5x4. Now, we copy the same sign. We got minus 3. And we are going to do the derivative of this. X to the power of 3. We already have that because we did it before. So the derivative of x to the power of 3, we put the 3 down. 3. We copy the same x. And instead of writing x to the power of 3, we write it as a 2. And then between these two numbers, it's just a multiplication. Lastly, what we have is plus x. The derivative of x is just 1. To make it more clear, we got 5x4. 3 times 3 is just 9. X squared, well, plus 1. Just like that, we are done. That is the result. Now, to continue with this, we have this exercise, and we are going to be a little bit faster here. So again, for the number, I'm just going to copy the number. We have a polynomial. Remember, we take down the exponent. In this case, is 6, x to the power of 5. Then we got 2 times. Remember, this is another polynomial. So we are just going to copy the 2. Then we are going to do the derivation here. So this is 4x to the power of 3. And then we got 5 times 2x to the power of 1. Now, if we do the multiplication, the result is going to be just 2. 6 divided by 3 is just 2. 2 times 4 is just 8. 5 times 2 is just 10. And, well, sorry, I put 4. This is supposed to be 1. And just like that, we are done. That is the result. That is the result. And also for this other two, these are the results. Let's continue. Now, for these exercises, I want you to check that I include in the formulas, I include this type of exercises, but there is more than one way to do it. For example, here, when I want to do the derivative, I put one formula, which is, in fact, is this one. It is going to tell me what to do whenever we have something down here. When you got something down, it's we have to do like instead of subtracting, we have to add. Like you can see here. What do I mean by that? This is telling me this is A. Okay, this is A. So this is A. And this is U to the power of n. To make it clear, this is x to the power of 1. So U is x and n is 1. So whenever we want to do this type of exercise, what we have to do according to the formula? We put a negative sign, so it's going to change the sign. We put a fraction. We copy the a, okay, so the a in this situation is just 1. Let me write it, 1 times. Then we got n. In this case, n is just 1 again, but I'm going to write it as red to avoid any confusion. Sorry. And then we had u prime. In this case, x is the same as u. So if I want to do the derivative, because this is meaning the derivative of, again, the derivative of x is just 1. So here we have three different ones, but they come from different places. This number 1, the first one, comes from this. Okay, so this one comes from this one. The other number 1, which is in red, is the exponent right here. And the third number 1 is the derivative of x. The derivative of x, we know is 1. Now, maybe here you will say, okay, so we just write 1, that is correct, but we need to understand what we are doing. Then what do we have? We have n plus 1. So instead of x, we have u. So this is going to be x. If the exponent here is 1, down here is going to be 2. Therefore, our result is going to be, let me move this a little bit. Therefore, the result is going to be y equals minus 1 over x to the power of 2. Now, maybe here you will realize, oh, so what we have done is that we change the sign. We change the sign and we add one exponent to the number down. That is absolutely correct. That is what we have done. So there are different ways to do this. Last year, how you learn it? Instead of writing this, you write x to the power of minus 1, and you follow the classic formula, this one, which is also correct, but it's going to give me the same result. Look, if we do the derivative here, the minus 1 will be, it's going to the front. Then we have x minus 1 because we have to subtract. And then we got minus 1 times x to the power of minus 2. As you can see what is happening, this is minus 1, this goes down, and it's going to be x squared. Now, if you take a look and we compare the answers, we have the same thing. The result up here is the same as the result with the other formula. There are more than one way. There is than one way to do it. But to be honest, I prefer to stick with the formula. If you want to do it this way, it's also correct. Now, to make sure you're paying attention to the video and, well, as a way for me to do that, you are following the video. You got this exercise. It's going to be for 5 extra points in the diagnostic exam. So, well, I don't know if you're watching or you just saw the link in the Teams group, but if you're paying attention here, come to me whenever you can and tell me, Mr. I did exercise. So let's continue with this. If we continue, well, let me erase it because I don't want to leave it for the whole video. We got this number 9. Let me write a little bit of a space because now it's getting crowded. Number 9 says that we have y equals 5 over x to the power of 4. If we do the derivative and we follow the formula, here I delete the formula. What do we have? According to the formula, we have a number up here. In this case, the number is 5. We have x to the power of 4, which represents the u to the power of n. So what we have to do is, again, change the sign. Instead of a, we have 5. Okay, we have 5. Instead of n, we have 4. Okay, so this is times 4. I've got the u prime. Remember, in this case, u is just x. So if we do the derivative of x, the only result is going to be 1. What else do we have? We have an exponential that is doing addition up here. So we have x. We copy the same exponent, but we added 1. What is going to be the result? Minus 20 over x to the power of 5. Yeah, just like that, we finish this exercise. All right. This will be the first part. We are going to continue with everything, don't worry, but I don't want to do this quite heavy for you. So thanks for watching and let's wait for part number 2.